What if one day, humans actually lived on Mars? Imagine humans walking on another planet, not just visiting, but living there, building a new home among the stars. It sounds like science fiction, but we're getting closer to turning it into reality. From creating oxygen from thin Martian air to finding water hidden beneath the surface, to building homes that can withstand the harsh Martian elements, we are actively working on making Mars livable for humans. The journey to Mars is a testament to the indomitable human spirit, our endless curiosity, and our drive to explore beyond the horizon. It's about pushing the boundaries of what's possible and inspiring generations to come. This is the story of how we turn a red planet into our second home. Now you might be asking, why Mars? Why journey across millions of miles of space to this cold, desolate world? Well, of all the planets in our solar system, Mars is the most like our own. It has a day length of 24.6 hours, just a tad longer than an Earth day. It has seasons, just like we do, although they're twice as long due to Mars's longer orbit around the Sun. And crucially, Mars has frozen water, a key ingredient for life as we know it. But let's be clear, Mars isn't exactly a welcoming paradise. The Martian air is thin and unbreathable, composed mostly of carbon dioxide. With ingenuity and the right technology, we can overcome the obstacles Mars presents. Let's talk about the air we breathe, or rather, the air we breathe on Mars. You know that oxygen is essential for human survival, but the Martian atmosphere contains a measly 0.13% oxygen compared to Earth's generous 21%. That's where MOXIE comes in, the Mars Oxygen In Situ Resource Utilization Experiment. This ingenious device, about the size of a car battery, hitched a ride to Mars aboard NASA's Perseverance rover. MOXIE is a game changer. It inhales the Martian air, which is mostly carbon dioxide, and through a process called electrolysis, it isolates the oxygen atoms. It's like a mechanical tree, transforming the Martian atmosphere one breath at a time. Imagine a scaled-up version of MOXIE, a whole forest of these mechanical trees, working tirelessly to create a breathable atmosphere for a future Martian colony. By producing oxygen on Mars, we can lighten the load for future missions, making return trips from Mars more feasible. We all know the saying, water is life. It's as true on Earth as it would be on Mars. And while Mars may seem like a dry, dusty desert planet at first glance, it actually holds vast reserves of water, frozen beneath the surface. Scientists have discovered ice caps at the Martian poles, composed not only of water ice but also frozen carbon dioxide, what we call dry ice. Accessing this Martian water is crucial for any future human settlement. Water can be used for growing crops, producing oxygen, and even creating fuel. Now imagine yourself standing on the surface of Mars. The air is thin, the gravity is lighter, and the landscape stretches out before you in shades of red and ochre. But where do you live? Where do you find shelter from the radiation, the dust storms, the extreme temperatures? We need habitats, homes designed for Martian living. One idea is to use Martian soil itself as a building material. 3D printing technology could be employed to create structures layer by layer, using a special blend of Martian dirt, binding agents, and perhaps even recycled materials from the landing modules. Another concept involves going underground. Lava tubes, natural caves formed by ancient volcanic activity, could provide ready-made shelters from the harsh Martian environment. These subterranean havens would offer natural protection from radiation and meteoroids, and their stable temperatures would reduce the energy needed for heating and cooling. We've tackled air, water, and shelter, but what about food? We can't exactly order takeout from Earth. Transporting enough food from Earth to sustain a long-term human presence on Mars would be incredibly expensive and logistically challenging. That's why we're exploring ways to grow food directly on Martian soil, or at least in Martian-like conditions. Scientists have been conducting experiments on Earth, simulating Martian soil and growing a variety of crops. Greenhouses bathed in artificial sunlight and enriched with a carefully controlled atmosphere will be essential for Martian agriculture. Hydroponics, a method of growing plants without soil, using nutrient-rich water solutions, also holds great promise for Martian farming. Establishing a human presence on Mars requires more than just the basics of air, water, shelter, and food. We need to power our Martian outposts, communicate with Earth, and develop sustainable systems that will allow us to thrive on this alien world. The Sun, a constant presence in our solar system, will be our primary source of energy on Mars. Solar panels, strategically placed to maximize sunlight exposure, will convert the sun's energy into electricity, powering our habitats, greenhouses, and research facilities. Communication with Earth is essential, but the vast distance between our planets poses a challenge. To stay connected, we'll rely on a network of orbiting satellites and powerful antennas on the Martian surface. We're not just exploring Mars, we're preparing to live there, to turn a cold, distant planet into a second home for humanity. Imagine children playing on the Martian plains, their laughter echoing through the thin air. Imagine looking up at night and seeing not one but two moons hanging in the sky. The knowledge we gain, the technologies we develop, and the spirit of exploration we ignite will not only propel us to Mars, but will also inspire generations to come. The Red Planet might just become our second home.